Did you know that every atom in your body, and indeed, every atom on Earth, was once part of a star? Yes, that's right. The very building blocks of life as we know it originated from the far reaches of the cosmos, in the heart of stars. Welcome to the Secrets of the Stars, where we unravel the mystifying process of stellar nucleosynthesis. Stellar nucleosynthesis, the process by which elements are created within stars, is responsible for the diverse array of elements found on Earth. From the oxygen we breathe to the calcium in our bones, each element has a cosmic origin story. Stars, through their life cycle, forge elements heavier than helium, enriching the universe with the complexity needed to create life. The universe is a cosmic forge, with stars as its blacksmiths, shaping and creating elements that eventually find their way to us. So, next time you look up at the stars, remember, you're not just made of stardust, you're made of star atoms. The birth of a star is a cosmic event of unimaginable proportions. Picture, if you will, a cloud of dust and gas swirling in the vastness of space. This is where our story begins. Under the influence of gravity, this cloud starts to collapse in on itself. As it does, the pressure and temperature at the core begin to rise. This is the stage set for the process of stellar nucleosynthesis, the creation of elements within stars. In the heart of the newborn star, something extraordinary begins to happen. Hydrogen atoms, the simplest and most abundant element in the universe, start to come together. Under extreme pressure and temperature, these hydrogen atoms fuse to form helium in a process known as hydrogen burning. This fusion releases a tremendous amount of energy, causing the star to shine brightly. And that's just the beginning of a star's life. As a star ages, it begins to fuse heavier and heavier elements. In this celestial kitchen, stars cook up almost every element in the universe. Let's take a closer look at this process. In a star's core, where temperatures reach millions of degrees, hydrogen atoms are squeezed together under immense pressure. This fusion process creates helium, releasing a tremendous amount of energy which pushes outward, balancing the inward pull of gravity and keeping the star stable. This is the first step in a star's life, and it's just the beginning of the element creation process. As the star ages and its core runs low on hydrogen, it starts cooking up heavier elements. Helium atoms fuse together to form carbon, and carbon atoms fuse to create oxygen. This chain reaction continues, producing heavier elements like neon, magnesium, and silicon. Each fusion process releases energy, keeping the star glowing bright and stable. But here's where things take a turn. When the star starts creating iron in its core, the fusion process no longer releases energy. Instead, it requires energy. Iron is like the uninvited guest at the party who eats all the food and doesn't bring anything to share. This is a critical point in a star's life. The energy balance that kept the star stable is disrupted. The star begins to contract under its own gravity, setting the stage for the next dramatic phase of its life. So the life of a star is a continuous dance between gravity and fusion. It's a journey of transformation of hydrogen atoms becoming helium, carbon, oxygen, and eventually reaching iron. It's a cosmic tale of creation, where every element on the periodic table, except for a few light ones, is produced within these fiery celestial bodies. But what happens when a star runs out of fuel to burn? Well, that's a question that leads us to the dramatic finale in the life of a star. But we'll save that story for the next scene. Stay tuned, because the real spectacle is just about to begin. The death of a star is as dramatic as its birth, if not more so. Imagine a celestial sphere, a star, exhausted after billions of years of nuclear fusion. It has been creating elements in its core, building up layers like an onion, from hydrogen to helium, all the way up to iron. But here's the catch. The formation of elements up to iron releases energy, fueling the star's radiance. But the creation of any element heavier than iron requires energy rather than releasing it. So, what happens when a star accumulates a core of iron? It can no longer sustain itself through fusion. The core collapses under its own gravity, creating a shockwave that explodes the outer layers of the star. This cataclysmic event is what we call a supernova. In the extreme temperatures and pressures of a supernova, for a brief moment, the rules change. Elements heavier than iron can form, from gold and silver to uranium and plutonium. But these newborn elements don't stay put. The force of the supernova explosion scatters them across the cosmos. You see, the death of a star is not merely an end, but a beginning. These elements, flung out into the void, become part of interstellar dust and gas clouds. They can eventually coalesce into new stars, planets, and yes, even life. Every atom in our bodies, in the air we breathe, in the ground beneath our feet, was once part of a star. We are, quite literally, stardust. So, the next time you gaze up at the night sky, remember this. Those twinkling lights are not just distant suns. They are the forges of the elements, the creators of the universe as we know it. They are the past, the present, and the future all at once. And when they die in a blaze of glory, they sow the seeds of new stars, new worlds, and new life. So supernovae are essentially cosmic seed spreaders. Enjoying the journey so far? If you're finding these stellar facts as fascinating as we do, why not join our community of space enthusiasts? Hit that subscribe button to keep up with our latest videos. And if you're liking what you're learning, give us a thumbs up. Your likes help us reach more curious minds like yours. Don't forget to share your thoughts or ask any burning questions in the comments section below. We love hearing from you. Now, back to our cosmic journey. From the heart of a dying star to the building blocks of life. Welcome to the fascinating world of cosmic chemistry, where the elements that make up everything around us, from the air we breathe to the very cells in our bodies, are born. It's an awe-inspiring thought, isn't it? Each one of us is, in essence, a child of the stars. But how does this happen? It's all down to a process known as stellar nucleosynthesis, the cosmic forge where elements are created. Stars, like our Sun, are mainly composed of hydrogen and helium. Through nuclear fusion, these light elements combine to form heavier ones, like carbon and oxygen. These elements are the building blocks of life as we know it. Without them, life on Earth would not exist. Imagine, the carbon in your body, the oxygen you breathe, were once at the heart of a star. Each breath you take, every beat of your heart, is a testament to the life and death of stars billions of years ago. When a star explodes in a supernova, these heavier elements are scattered across the universe. They become part of interstellar dust and gas clouds, which eventually coalesce to form new stars and planets. And on at least one of those planets, Earth, these elements came together in just the right way to spark life. It's an intricate and delicate process, a cosmic dance choreographed by the laws of physics and chemistry, and it's happening right now in the heart of every star you see twinkling in the night sky. So next time you gaze up at the stars, remember this. You're not just looking at distant suns, you're looking at your distant relatives, the ancestors that made your very existence possible. The universe is in us as much as we are in the universe. We are all part of this grand interconnected cosmic web. So, we really are made of star stuff. So, what have we learned from our cosmic journey? We've embarked on an interstellar voyage, diving into the heart of stars where the magic of stellar nucleosynthesis happens. We've witnessed how stars, those shining beacons in the night sky, are more than just beautiful spectacles. They're the cosmic factories that create the elements that make up the universe, and indeed, us. We've explored the birth of a star, where hydrogen atoms come together in a fiery dance to create helium, releasing energy in the process. This is the beginning of a star's life and the start of the elemental creation process. We've delved into the life of a star, where heavier elements are formed. Through the process of fusion, elements up to iron are created, each stage releasing more energy and keeping the star alive. But it's in the death of a star where things get truly exciting. In the cataclysmic explosions of supernovae, elements heavier than iron are formed. These elements are then spread across the universe, seeding future stars and planets and even life itself. We've also discovered that these processes are not only fascinating, but vital. For without stellar nucleosynthesis, we wouldn't have the elements necessary for life. The carbon in our bodies, the oxygen we breathe, even the gold in our jewelry, all were once forged in the heart of a star. Next time you look up at the stars, remember, you're looking at the cosmic factories that made you.